This video covers the OSI model. OSI stands for Open Systems Interconnection, and it's a 7-layer framework that describes how network communication works from end to end. You don't need to memorize every detail of every layer, but understanding what each layer does and what happens when something at that layer fails will help you reason about network problems and about where security controls need to be placed. Experienced IT engineers use this model constantly when troubleshooting. Is this a layer 1 issue or a layer 3 issue? Tells you immediately whether the problem is a physical cable or a routing misconfiguration. By the end of this video, you'll be able to think the same way. The OSI model divides this network communication into 7 layers. Each layer handles one specific job and passes work to the layer above or below it. Layers don't need to know how the other layers work internally. They only need to know what they receive and what they hand off. Think of it like a manufacturing plant with 7 departments. Engineering creates the product specification. Design formats it for production. Planning schedules and sequences the work. Production builds it. Quality control verifies the output. Logistics packages and ships it. Facilities maintains the floor and the conveyors. Each department does its job, hands off to the next, and doesn't need to know the internal details of what the other departments do. A failure in one department shows up as a problem for the departments that depend on it, but the failure is isolated. Networks work the same way. Each layer adds something, and when communication fails, the layer where the failure happened determines what kind of fix is needed. As we start at the top, the application layer, or layer 7, this is where the actual service lives. This is what a user or software system interacts with directly. A web browser using HTTP, a SCADA client polling a PLC, an HMI reading real-time values from a historian, an email client sending a message. All of these operate at the application layer. The application layer defines what the data means, how the request is structured, and how the response is interpreted. In OT environments, all of the industrial protocols operate at the application layer. Modbus, DNP3, Ethernet IP, Profinet, OPC UA, all define application layer rules. How a read request is formatted, how a write command is structured, what a valid response looks like. When you're troubleshooting a failed SCADA poll, if the physical connection is fine and the IP addressing is correct, the problem is likely at this layer. Either the protocol configuration, the register mapping, or the service itself on the destination device. Below the application layer, we have 6 more layers that handle delivery. The transport layer, layer 4, manages how data is delivered between applications. This is where TCP and UDP live, which we'll cover in detail in the next video. TCP provides reliable ordered delivery with acknowledgement. UDP provides faster, lower overhead delivery without acknowledgement. Each serves its own purpose. The network layer, or layer 3, uses IP addresses to route packets from source to destination across networks. Routers operate at this layer. When traffic needs to cross a subnet boundary or travel across a WAN link, the network layer handles it. IP errors and routing misconfigurations show up here. We already discussed IP addresses and switches, and of course they work at this layer. The data link layer, or layer 2, handles delivery within a single network segment. Switches technically operate at layer 2 when 2 devices are on the same subnet. The data link layer uses MAC addresses to get frames from one device to the next. Switch configuration problems and VLAN issues show up here. We also talked about MAC addresses and ARP in a previous video. The physical layer, layer 1, handles the actual transmission of bits. Ethernet, Wi-Fi, and fiber all live here. Cable faults, bad ports, and duplex mismatches are all layer 1 issues. Now you notice I didn't say anything about layer 5 and 6. These are known as the session and presentation layers. They sit between transport and application. The session layer manages connection state, and the presentation layer handles data formatting and encryption at the protocol level. These layers rarely come up as a direct source of OT network problems, but sometimes you'll hear these numbers referenced in broader networking discussions. For purposes of our training, we don't really need to understand what happens at layers 5 and 6. The reason this model, the OSI model, matters for you is that it gives you a systematic way to approach any network problem. When a SCADA pole fails, you start at the bottom. Is the physical link up? Check the LED port on the switch. That's a layer 1 question. Does the IP address look right? Ping the device. That's layer 3. Can you reach the default gateway? If not, the issue is a layer 3 routing problem. Can you reach the destination IP address? If not, it's a routing or a firewall issue somewhere between subnets. Is the service actually running on that destination? If yes to everything else, but the pole still fails, it's a layer 7 issue or application layer. The service configuration, the protocol settings, or a firewall rule could be blocking that specific port. We'll work through a structured troubleshooting process exactly like this in Module 6. For now, the key takeaway is each layer is independent, each layer fails in its own specific way, and the OSI model tells you where to look. In the next video, we'll go deeper on the transport layer, covering TCP versus UDP, the core trade-off between reliability and speed, and which OT protocols use each.